Concurrent engineering. 1. Concurrent engineering is an approach to product development that emphasizes cross-functional collaboration and simultaneous involvement of various disciplines and stakeholders throughout the design and manufacturing process. 2. It aims to reduce time to market, improve product quality, and enhance overall efficiency by integrating design, engineering, manufacturing, and other functions early on. 3. Concurrent engineering enables early identification and resolution of potential issues, such as conflicting requirements, technical challenges, or manufacturing constraints, reducing the risk of costly changes later in the process. 4. It promotes simultaneous and parallel activities, allowing different teams to work concurrently on different aspects of the product, leading to faster development cycles and improved productivity. 5. Concurrent engineering facilitates communication and information sharing among different departments and stakeholders, fostering a collaborative and interdisciplinary work environment. 6. It involves the use of tools and techniques, such as computer-aided design, CAD, simulation, and virtual prototyping, to enable real-time collaboration, visualization, and evaluation of design alternatives. 7. Concurrent engineering encourages early involvement of suppliers and customers in the product development process, allowing for their input, feedback, and expertise to be incorporated from the beginning. 8. It emphasizes the consideration of multiple factors, including cost, manufacturability, maintainability, and sustainability, in the early stages of design, ensuring a holistic approach to product development. 9. Concurrent engineering supports the integration of various product lifecycle stages, from concept development and design to manufacturing, assembly, and even post-sales support, leading to better coordination and seamless transitions. 10. It enables rapid iteration and prototyping, facilitating quick feedback loops and iterations to refine and optimize the design, resulting in improved product performance and customer satisfaction. 11. Concurrent engineering promotes risk management by identifying and addressing potential risks, such as technical uncertainties or supply chain disruptions, throughout the development process. 12. It encourages the use of cross-functional teams with diverse expertise and perspectives, enabling a comprehensive and multidisciplinary approach to problem solving and decision making. 13. Concurrent engineering emphasizes the importance of standardization and modular design, allowing for the reuse of components, designs, and knowledge across different product lines or projects, improving efficiency and reducing costs. 14. It enhances the ability to meet customer needs and expectations by incorporating market research, user feedback, and market trends into the design and development process. 15. Concurrent engineering facilitates the consideration of regulatory and compliance requirements, ensuring that the product meets necessary standards and regulations from the early stages of development. 16. It enables better resource allocation and optimization by considering factors such as material availability, equipment capabilities, and production capacity during the design phase. 17. Concurrent engineering promotes a proactive approach to problem solving, encouraging the early identification and resolution of design conflicts or technical challenges to avoid costly delays or redesigns. 18. It supports knowledge transfer and learning within organizations, as information and expertise are shared and integrated across different departments and disciplines.